Good day, guys. Today we'll be looking at phases and we'll be solving some questions on phases. Okay, so this is our first problem. They said four circuit elements are connected in series across a sinusoidal alternating voltage given by this equation. So the instantaneous voltage across the three of the terminals are given by V1 is equals to this, V2 is equals to this, and V3 is equals to this. Determine the expression for the fourth voltage in the form V4. What is the RMS value of V4? So in this question, they are simply telling us that we should calculate V4 and calculate the RMS value of V4. But they say the four circuit elements are connected in series. So if they are connected in series and the voltage source was E, we can say that the E here is equals to V1 plus V2 plus V3 plus V4. And since we know this, we can simply make V4 the subject to calculate for V4. So this is what we'll simply do. So in this video, I want to use complex numbers to solve this question. I'll mix complex numbers with phases to solve this question so that they understand how it goes. So first of all, we have to convert the given voltages to phases. So realize that how do we convert this voltage, the E, the 110 sine WT plus 30, we can simply convert it to phases by just taking the magnitude and the phase. So the magnitude of E, for E, the magnitude is 110 and the phase is 30 degrees. So we'll just do the same for V1, V2, and V3. So doing that for V1, V2, V3, realize that for V1 is 30 phase 0 because there's no angle. That is why it's phase 0. And for V2 is 60 phase 60. So that is it for V2, 60 phase 60. V3 is 30 phase minus 30. Please, minus 30. So you see that this one was plus, this one it was plus. That's why it was plus plus. Then after doing this, we now have to also apply KVL, just as what I did here. This I applied KVL. So applying KVL, it says the voltages, they were in series. So V1, V2, V3 is equals to E. This is it. So doing that, we just make E a V for the subject. Making V for the subject becomes E minus V1 plus V2 plus V3. So after doing this, we can now change. We need to change V into rectangular form. How do we change it into rectangular form? We have to change it to have the x component and the y component. That is where we have cos cos theta plus j sine theta. So this is the x component, this is the y component. So doing that, we have to convert this, the 30 plus, because the V1, it has no distance j component. It was just 30. So 30 plus j 0 V1. So converting it becomes 30 cos 0. Then to convert V2 to, we have to do the same thing. So V2 was 60 angle 60, so it becomes 60 cos 60 plus j 60 sine 60. So doing that, we come and get this equation. We'll do the same thing for V2, V3 as well. Doing that for V3, we come and we have our equation as this. So these are our equations we got. And after that, let's also do it for E. Doing it for E, the magnitude was 110, 110 cos 30, that was the angle, plus 110 sine this. Doing the mathematics, this is what we get. Then we simply now subtract E from V1 plus V2 plus V3. Doing that, so let's first of all just add it to get the symbol. So to add it, we add the x component, all the x component. Realize that this the x components don't have the j. In mathematics, in algebra, it was I, but here, because I is current in applied electricity, we can't bring I here. So that's why we are using j. So we add these components. So after adding these components, that's why we added them here. The 30 plus 25 point this plus this. That's why we got this answer. After getting these answers, we now come and after getting these answers, we now come and also add the complex part. So this is the complex part. Let me use a different color to denote it. This is the complex part in green down, denoting them in green. We'll add the complex parts too. So adding the complex part, this is what we get as our final answer, adding V1, V2, V3. Then we simply subtract it from the E. So this was our E. This is our E. So we now subtract it from our E. We subtract it from our E. After subtracting it from our E was 95.26 plus J55 minus our 85.98 plus J36.96. So doing that, we come and get our final answer for V4 as 9.28 plus J18.04. Then after doing this, they said we should find the distance, the expression for V4, but this is the expression in rectangular form. Let us also find the angle so that we can put it in a sine form. So to find the angle, we simply find the magnitude. And how do we find the magnitude? We square this square, this one square plus this one square, all square root. So finding it, this is how we do it. So we do it this way. So it becomes the 9.28 square plus 18.04 square, all square root, is equals to, and we had our 20.28. Then we also need to find the angle. So finding the angle, this tan theta, the tan inverse all over the y component all divided by the x component. Doing that, we come and get our angle as 62.57. And now express V4 in the sinusoidal form. So what was our distance? Our magnitude was 20.28 sine omega t plus 62.57. So this is how we express it. So our V4 now becomes this. After expressing our V4 as this, we can now find the RMS value. How do we find RMS value of a sinusoidal waveform? We simply divide the maximum value by root 2. So doing that, we find the RMS value of this by the amplitude over root 2, that is the 20.28 divided by root 2, and this is the answer we get. So at the end, we get 14.34 volts as our RMS value for the voltage. So this is how we simply calculate the RMS value of phases using complex numbers. So thank you very much for watching. Please remember to like, share, and subscribe for more contents like this. Please click on the notification bell for more so that you'll be notified whenever we post a video. Thank you.